Hello, Internet. We meet again. This new paper, written by Baz mostly, and it includes some interesting ideas here. This paper is called The Percentage Ratios for Life in Stellar Metamorphosis. Now, of course, all of this is subject to change and interpretation and moving things around, but this is where we're essentially headed with it. Here's a big ratio diagram. I'll link this to the bottom of the page as usual. But if you look at it with me, it says here 350 million years shining to dimming brown dwarf, so 0.5% of a star's evolutionary path is like this much. Very, very, very short period of time. You can see right down there that the star is actually shining and then it goes down to a brown dwarf and it ceases radiating strongly. And the window for life is 38%, and then you get to about 40 billion years, the desolate years it has on here, where there's just no possibility for life to be hosted. That's where the really old stars are, like Venus and, dead moons that are over here in this general area. And people need to remember that when they look at this graph, it's essentially exponential or logarithmic, whichever one. The short years, they look like they're long, but if you look down at the graph, it's actually extended out greatly. Up to 350 million years, that's where it's cut off. It's for the most part arbitrary, but it sets a standard for, what we're referring to. And at 350 million years, then boom, it goes straight to like 5 billion. Now that's a third of a billion to 5 billion, and this is a third of a billion right there, all the way up to 5 billion down here. So there's a huge amount of time that life can form on the star, and it's also very important to notice how short of a time frame the star shines for. So all those stars we see in the night sky, they're very short-lived, quick. There's a word for it, I can't remember, it starts with the E. But it's a very short phenomenon when the star is very young and shining and bright. And it makes a lot of sense, because why in the universe would something that's so energetic, such as a star, last for billions and billions of years? That doesn't make any sense at all. If something's really energetic, it's common sense to be like, well, those are probably the most short-lived objects. And for it to evolve on longer scales of time, it needs to cool down so it doesn't lose all that energy. It becomes less energetic. And that's where life forms, is when it's less energetic in this general area. And then eventually it just leaves the leftover remains. And the majority of the star's life, per se, is just it's wandering around the galaxy, smashing into other objects, destroying itself. And of course, that's just a representation of how long of a scale of time we're dealing with here. And it's a very, very different way of looking at the stars in the night sky. Because currently scientists, they look at stars in the night sky and they say, well, these super energetic objects are powered by fusion for billions of years. No. They're very short-lived things. And the majority of the objects in our galaxy no longer shine. You can't see them. So I would expect the test, which is called the Transiting Exoplanet Survey Satellite, or Satellite Survey, which I can't remember which one it is, but that's going to find many tens of thousands of objects that no longer shine via the transit method. And that being said, just so people can get a grasp on how long it's taken for humanity to get where it is, even in the context of how long it takes a star to evolve. As of November of 2017, scientists have found the earliest known human ancestor, and as it turns out, it's similar to a rat. So you can make a T-shirt out of this. Check it out. There it is, right there. And then you scale up, and the time frames for human evolution are also kind of similar to the time frames for life, but I guess backwards, if you will. Like, the amount of time that humans have been in this area has been the shortest, but in the past, the other stages took a lot longer. It says here, paleontologists from the University of Portsmouth, of course I'll link this to the bottom of the page too, have discovered fossil teeth from 2 rat-like creatures in Dorset, England, which scurried around Earth approximately 145 million years ago. Scientists say they can draw a direct evolutionary line from these small furry animals to the people that walk the Earth today, and have announced that these 2 species of rat are the oldest known ancestors of human. And they're called Duralstotherium and Duralstodon. There's their, what you call them right there, and Duralstodon. So named after Durlston Bay in Dorset, where the fossils were found, the area has been nicknamed Jurassic Coast, as it has produced an immense number of dinosaur fossils. And I also pulled up a picture of these 2 little mamma jammas with next to a dinosaur-like bird-type creature. They're just chilling, and you see the much larger animals, other I think Brachiosaurus, maybe something in the background. But I think it's cool how they can put these conceptualizations, you know, they can make pictures of these with artist impressions and stuff, so you can really get what it is they're referring to. And I think it's also really cool because it shows the larger dinosaurs walking around in water. Because I sincerely believe that that's how the majority of the large dinosaurs were getting around, was they weren't, you know, walking on land. The majority of the large dinosaurs were walking around in water, in large flat plains of water and swampland and that kind of stuff. They were semi-aquatic creatures. At least that's what I believe is true. That's why they could become so big. And Earth had a lot more water on it in the past, so clearly you scoot back 145 million plus years ago when there was a lot of water. Of course there's going to be lots of dinosaurs. Anyways, I think I made this video long enough. Baz, good job on the paper, and most importantly, I think it's the new worldview that we should adopt is that we can't look at the Earth as being something that just formed 6,000 years ago, and also we can't look at scientists and their claims of the universe exploding into existence 13.7 billion years ago as if it had a beginning. That's not a good way of looking at it, because, you know, Venus and Mercury, they're older than that by themselves, and they're wandering around like giant rocks in outer space. They're 25 to 65 billion years old. So how could the universe have a beginning if there's objects inside of it that are older than the claimed age of it? I just think looking at things as having a beginning itself is kind of like strange, especially when it's scaled up to like the universe. I don't think scientists can comprehend a single galaxy, much less all of existence. I don't know. I think they got way too ahead of themselves, especially when we're just starting to discover who our earliest mammal ancestors are. I mean, don't you think it's kind of like jumping to conclusions? All right, later, y'all.